Today we're looking at a worksheet for Boyle's Law and Charles' Law, and we're going to work through question number 1, question number 5, and then we're going to do a couple examples on the back, 11 and 12. So a couple things to notice. You've got an answer bank up here at the top. You've also got, you have a little space over here. You should write your equations. Let's do the Boyle's Law equation is P1V1 equals P2V2. And we know that relationship is indirect, and when pressure increases, volume does the opposite, it decreases. So if pressure decreases, volume increases. And when we start with number 1, we know we're doing Boyle's Law because it tells us. And we're going to take a look at all the numbers that are given. All these are important. And a strategy for you is to simply go through and label everything. So we know milliliters is volume. We also see a Q here that tells us volume. So we know we want to label it V, and it's the first volume you come to, so let's label it V1. And then we have a pressure that's connected to that volume, so we should call that P1. And then we have a question word asks us to solve for volume, so we'll call that V2, and we'll put a question mark there, so we know that's what we're solving for. And then we have a pressure associated with that, and we'll call it P2. And at that point, you just plug your numbers in for your variable. I'm going to follow this equation while I do it. And so I need P1 first, so I'm going to do 740 times 250 equals 800 times V2. And you notice that I didn't put units in here. That's just to make my math a little bit easier. The thing I need to check on with units is that the pressure units match. So P1 is in torrs, P2 is in torrs. When I solve for volume, my unit should match V1's units, so I know it's going to be something milliliters. Now to solve for V2, I'm going to need to divide both sides by 800 so that I get V2 by itself. I got to do the same thing over here. I don't have a lot of space. I'm just going to squeeze it in. So your calculator, you should put 740 times 250 divided by 800. I'll give everybody a second to do that. When you get an answer, check with your answer bank, and you should have 231. And you can cross that one out because you've used it. And now it's time to go on to question 5. Alright, we're looking at number 5 now. We see that we're in Charles' Law. So somewhere you could write your equation. You can write V1 over T1 equals V2 over T2. Those are related directly, so when one increases, the other does the same. And this may come in handy at some point. You can also write, it works to do it the other way, T1 over V1 equals T2 over V2. And directly means one increases, so does the other. So if T increases, V increases. If T decreases, V does the same. Okay, so number 5, we've got a sample of nitrogen at a volume of 250 milliliters and 25 degrees Celsius. What volume, so that means V2 is what we're going to be solving for, will it occupy at 95 degrees Celsius? Our first volume is 250, call that V1. Our first temperature is T1, and we see that it's in degrees Celsius, and we've talked about how temperature needs to be in Kelvin. To get Kelvin, you just take your Celsius temperature and you add 273 to it. So the T1 we want to use is 25 plus 273. which is 298. And we are going to call this T2, but again we have to add 273 to 95, and that value is 368. So I would definitely make a little note of this equation, and you could even draw an arrow showing that that's how you got that. Okay, now you're ready to plug your things into your equation. So we've got, we could follow the first one here, V1 250 over T1 298 equals V2, remember that's what we're solving for, over T2, which is 368. And then at this point, you've seen lots of problems like this in math. You just cross multiply. So we get 250 times 368 equals 298 V2. Divide both sides by 298 so you can get your V by itself. And volume is 309. Units match V1's units, so that's milliliters. Alright, we're on the back now. We're going to look at 11 and 12. And you'll notice that these are all mixed up, so you are learning now how to identify which law to use if they're not telling you. We've got 300 Kelvin. Let's go ahead and call that T1. You see that the units are what we need them to be. 500 milliliters, V1. To what temperature? So temperature is what we're solving for. It's got to be T2. And to what temperature should it be lowered to bring the volume to 300 milliliters? That's V2. If you label like this, it's easy to see what law you're going to use. You have temperatures and you have volumes, which means Charles' law is your law. So you can go ahead and write the equation if you'd like to. V1 T1 equals V2 over T2. And then you plug your numbers in. So we've got 500 over 300 equals 300 over T2. And you notice you have two numbers the same here. That's okay. That can happen. You just have to be really careful that you don't get confused in that situation. So we have 500 T2 when we cross multiply equals 300 times 300. Solve for T2 by dividing both sides by 500. Plug that in your calculator. Give everybody a second to do that. And you should have had around 180 Kelvin because we're matching our unit to T1's unit. And that should be one of your choices in your answer bank. Alright, one more example, number 12. We have 1.5 atmospheres, and they tell you that the pressure goes down to 0.5 atmospheres. Atmosphere is a unit for pressure, so we'll label this P1, and we'll label this P2. And then it says a new volume of 750. So we know that's a volume. If it's new, it should make sense that we would call that V2, and original would be V1. So this one is a little different because now we're solving for V1. So we would plug in our P1, which is 1.5. Now V1 is the variable we're solving for. And then we've got 0.5 for P2 and 750 for V2. Get V1 by itself. V1 is 0.5 times 750 divided by 1.5. Give everyone a chance to solve that in their calculator. And you should have 250. It's a volume, so we're solving for the same unit as V2, which is milliliters. Cross those two off in your answer bank at the top. And since we're given pressures and volumes, we know that this is Boyle's law. All right, you should be able to do the rest of the examples on your own.